Hello everyone, welcome to today's Novedge webinar, What's New in Creo 7. Product design is constantly changing, and so should your CAD software. Creo 7 has breakthrough innovations in the areas of generative design, real-time simulation, multi-body design, additive manufacturing, and more. With Creo 7, you will be able to design the most innovative products faster than ever before, keeping you on the cutting edge of product design. So very exciting. And let me tell you a little bit about Paul. Paul Dye is an application engineer with PTC and a member of the Virtual Center of Excellence. He comes equipped with extensive knowledge of Creo, along with many of the powerful extensions that supports Creo's parametric modeling capabilities. And now here's where you can find the new Creo 7 and Novedge.com. Novedge is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, faster service without any headaches, which is a great perk. And I also want to let you know that this week we have a promo for a CAD 3D workstation that it's perfect for Creo. So many webinars they ask, us what hardware is necessary, what's the best ideal setup for working with Creo. Here you have it, and now it's $200 off. But enough about me. I'm going to switch the screen and let Paul take it away for the presentation. Okay, we're switching screens. Stay with us. Great, Paul. I can see your screen. The stage is all yours.
All right, perfect. Thank you very much. And again, my name is Paul Dye. I am an application engineer here with PTC, and I primarily work with everything Creo. And so that's really what we're here to talk about today, is exactly what we have new coming in Creo 7.0. And to go over everything that's new in Creo 7.0 would take much longer than 30, 45, even an hour to talk about. So I'm going to hit on a lot of the main points today. And then obviously, if there's anything that you're interested in or anything that you wanted more information on, you can definitely reach back out after the fact and get that for you. And so starting into it, the first thing I'm going to touch on is just some of the main core capabilities and core modeling features that we've made enhancements to. And so the first thing here we have is improvements to the import data doctor. If you're doing things like bringing in non-native geometry, well, we now have support for things like multibody. And in this import data doctor, there's also a troubleshooter that's looking for things like open quilts and how we find and fix those. So definitely important if you're working with non-native CAD data, and if you're bringing that type of stuff into Creo, definitely need to have all the tools around you to do that. We have also new display filters for our geometry representations. This could be utilizing that new multi-body capability we have in Creo now. So if you wanted to, say, display a lattice type that you have here in the middle of this feature, and you want to make the rest of it a little bit more transparent, you have a lot of options to do that all the way through your part. We've also made enhancements to things like the draft feature, and that includes drafting already drafted features. So if you have those features already drafted, you go ahead and draft right on top of them. And we also have the ability to detect existing draft angles in the model. So it's making it easy to work with and even modify later on. And finally, here we have improvements to the performance of snapping geometry, or snapping to model geometry, or even snapping to a grid. And that's kind of different workflows there, where if you're working with that geometry and if you really want to snap to those edges or snap to certain features, or if you want to turn that off, turn it on, it might change a little bit while you're working, so you have the ability right in the quick menu to switch between those if you need to. And moving forward, we've made enhancements to the mirroring tool in that sketcher. So it makes it very easy to grab things and mirror. You can now essentially grab any straight sketch and use that to mirror about. And if you want to change that sketch around, move around the dimensions, that mirror is going to update for those changes. So you can set it to update or set it not to. We have now improvements to the visualization, just in general, of your design intent in the sketcher. We've improved the look of our relations icons. We're able to highlight certain references, change colors, really just modernizing the look and feel to working in that sketcher to better display that design intent throughout. And then in the edit dimension section, you're able to set the appearance of your sketcher constraints. So when you click to edit those dimensions, also show the constraints. So that's just a config option that you now have the ability to activate there. So really, there's a ton of different core modeling capabilities that we've updated, but just a couple of them to reference on for you to see a little bit into that. But what I want to move in now is to look into a bit more into the applications. Starting here first with Creo Simulation Live, aka CSL. And if this is something that you haven't seen or even worked with before, this is a tool that we've developed as part of our partnership with ANSYS to put real-time simulation right into the modeling environment. So it's not some other software or another window that we have to jump over and to work with it, something that's available to us right in the modeling environment. And this was introduced with Creo 6 and actually backported into Creo 5 and 4 as well. But we've really been working on this and making rapid enhancements to it over the past year, and I can touch on a little bit of that right now. First thing that we've added is the ability to control the direction vector from a selection. So it doesn't have to be a default and we don't have to type in all the X, Y, Z. What you can essentially do is just, if you want to apply a load, you can say, okay, let me just simply select right on that face or right on that edge or whatever it is, and then it's going to, by default, fill in all of those direction vectors for you. And building off of that, we're now not locked to working with the overall global coordinate system. You can create and select any coordinate system to define those load cases from, so improving the general ability to define those loads from the start of the study. Also made enhancements to the legend, specifying what you want to look at, how those values are displayed, especially for setting things like the upper and lower bounds for the values that you're displaying. Works a lot better now. It really works well with things like composite views where you're only displaying values within a particular range on that legend. So say you're showing your model, but you only want to see values that are between 14.6 and 8.3, you could go ahead and move those down, and then it's making the rest of the area transparent or basically see-through and only showing the values in that particular region. So that's a really useful tool there, specifically when you're building out your designs. We can also use values that we get from our simulation probes in CSL and use them in our behavior modeling studies. If you haven't worked with behavior modeling before, this is something that allows us to take values like your maximum von Mises stress or the displacement that you're getting from your analysis and begin to kind of optimize around it, where we're telling the system certain dimensions that it can change, and the system goes through and automatically optimizes the model for us based on what you allowed it to change. So working with those variables, it's a really useful way to use those analysis results we're getting back from CSL. We've added more real-world simulation constraint types as well. So things like ball, pin, planar constraints, just helping to make more of those cases more realistic to the problem or the situation that you're trying to design around. And CSL now also has support for multibody design. There's a ton of different applications of that, things like cavities, internal, external volumes, domains, and much more around this. And then specifically to thermal studies, we can now do transient studies, aka time-dependent analysis. Allows you to see how the values are changing over the course of time. So now you can either do first steady state or either the time-dependent study, depending on what you want to look at there. And moving on from there, probably the biggest change to CSL with the release of Creo 7 is the option to do flow analysis in the same way that we do for structural, thermal, modal, where we essentially begin by creating the fluid domains, whether that's internal or external, which areas to include, the inlets, outlets, specify the materials for those domains, and from there being able to visualize it right on top of the model that we're working with. And that's the idea here, is regardless of whether it's an internal or an external case, be able to visualize it right in the modeling environment. And along with that, there's a ton of different options for the results that you're getting. Visualize the streamlines, the particles, take section views, direction fields, set probes. It's really a powerful, but at the same time, very easy to use tool for doing that type of flow analysis. It's not something that we have to send off to the expert analyst to maybe get results back later. You know, something that we can do right as we're working, right in the design environment. And so it's one thing to talk about that and say how great it is for visualizing, but it's probably a lot better to actually see what that looks like in the context of Creo. So we can hop over and go through a brief demonstration of what that looks like. So pulling up the part that we're going to be using here for our demonstration of the flow analysis in Creo Simulation Live, we're going to be working with a model for a muffler off of a motorcycle assembly. So this part actually came from one of our customers, Royal Enfield. So this is the muffler off of one of their data sets. What we'd like to do is simulate some of the flow that's happening within this system. So we can go ahead and open this up to see kind of what we're working with to start. And there's definitely a lot of great geometry in here that we're going to be able to utilize and begin to change around as we go further. So to start into that, we'll simply go right up into the top, into our live simulation tab, and click to start into a fluid simulation study. And the first thing we'll lay out is our fluid domain. So the fluid domain is the volume of space that our fluid flow is going to be contained within. If we want to do that, we'll first begin by defining here for this internal flow example, the inlet for the study, the outlet where it's leaving. And what the system does is it automatically builds out that internal volume for the model. And once we accept that, it appears down in the model tree, and it's something that I can go back to, I can make changes to later on if I'd like to. And from there, I can define my fluid material that I'd like to analyze. So we have a few base options laid out here that we can select through. And I'm going to start here with carbon dioxide. This is going to be a really close approximation for what's going to be coming out of my motorcycle. So go ahead and select that. Next, we'll give our study a fluid flow velocity for my muffler. Essentially, how fast is this going to be coming in from my motor? Specify the surface I want to work with, set the direction, set the magnitude from my options there, and simply lay that out. And now that I have that flow velocity set up, I can go ahead and set some thermal conditions as well, such as the prescribed temperature at that inlet. And around that, set the values, set the unit, whatever regular operating temperature that might be around that motorcycle exhaust. Now I'm pretty much happy with the initial conditions I have at that inlet. So next I'll define an outlet pressure for my muffler. So move around to the back end. And for my case, I'll just simply set it to 0, essentially just outside air. With that, I'm pretty much ready to jump into the study. We do have a couple quick options that I could go through and change here for my simulation quality. I can slide it all the way over to the left for the highest speed, keep it all the way over to the right for the highest accuracy, or maybe somewhere in between. In this case, I want it to be at the highest accuracy. With that, we can simply go ahead and click to simulate. And with that, we can essentially see as soon as I click to run the simulation, we're getting results back. It's really that fast. I can hop over into my legend, and if I only want to see the velocity within a particular range. Also have different display options that I can choose from to visualize the flow of individual particles through this. And with those particles, even more options to change the size, change the transparency, really getting this looking the way that I want. And so it helps me understand exactly how that flow is working, depending on how I set up my model. All right, those particles are one really good way to analyze the flow, but we have other ways as well. We could look at a direction field, which essentially acts as a cut plane that I can use to see the direction everything's going in. I can move that cut plane around to different parts of the model. Here I'll pull up our dragger tool, and we can use that to change it around, just check out different areas, see the direction that my fluid is moving based on how I defined it. So it really helps me to interrogate certain areas, even type in specific values for that section view as well. As we can see, there's a lot of different ways to visualize those results. But on top of that, also analyze and begin to build off of that. Starting here first with one of our live simulation probes, what that allows me to do is see different values in my model. See the maximum velocity maybe that we're getting down at our outlet. We can see how that changes over the course of the flow. Along with that, we can see those values. We can see a graph for those values, really helping us to understand what's happening down at that outlet. There's other options we could view through as well. So you can see pressure, temperature, vortices, and now these are all going to be things that we can begin to design around. And one of the ways we can do that is by working in the design exploration session. And this is our tool in Creo for trying out new designs, iterations, branching off of existing designs. And instead of how you would normally do it by creating lots of copies and doing save as all the time, we're working right within this exploration session, where we're starting into this with a pre-modified version of the model. And as we start to go through now and make changes, instead of saving off different copies for that, we simply just build out checkpoints at any place that we might want to build back on. In this case here, we have these internal baffles. What's going to happen if we want to take them and maybe make a couple of them a few inches longer? So even though we're in this design exploration session, we have the flow analysis running, we're still able to do this standard sort of CAD Creo work that we're used to. But the difference is now is as soon as I make that change, we're getting instant insight into what that does to the analysis. You can see the particle flow, see where the velocity is increasing or decreasing, especially important down by my end velocity, down by the outlet. We can check that probe, see the graph of the velocity. Again, this isn't something that I send off to hope to get results back by the end of the week. I go through, make the changes I want, and I get to see the results right in my environment. Like I said earlier, if you want to go through and build out a checkpoint with that, show that I increased the length of the pipes there, we can go ahead and do that with the use of the design exploration. It's keeping track of all those changes I'm making. What that allows me to do is keep making changes to my design. So maybe in a past design, I built these pipes with holes in them. Well, now I want to see how that design would work if I activated those holes. So right in the model tree, I'll activate those, and immediately we can start to see what that does to our results. So we can see we're getting a different flow, how that's changing here. We can clearly see we started to increase that outlet velocity, but we can check into other values as well. Maybe if we want to switch around between different views, switch to a composite view, check into seeing how the velocity is moving through the pipes, check the pressure, see those pressure drops. Looks like we started to smooth out the pressure flows throughout the model. Here we can go through and see a lot of different areas in the model, but similar to how we did with the direction field, we can also take more true section views to see what's happening at the different parts of the model. What we can do here is let's switch around to the back and take a bit of a closer look into the flow going through some of those holes that we added into those pipes. So we can see the difference with that, change it over to the direction field. Actually see we almost reversed the flow through those holes in the baffles. So I'm definitely happy with some of those changes I made so far. And to capture some of that design intent, I'll make a checkpoint, show right where I was whenever I made the changes for those holes. Something that I can check back on, switch between different checkpoints, really starting to capture the work that I've done throughout this design. And so from here, I'm pretty much happy with where I'm at towards the outlet. Now I want to direct my attention more towards the beginning of the flow. And right now, we basically just have a solid cylinder with a bunch of pipes going through it. But I want to change up that design. First thing we'll do then is to clear out that feature I have right now, and instead start with more of a clean slate that I can begin to add to as we go. And so we can also use one of our multi-body commands here to quickly remove that body from the model. And with that area now cleared out, we can begin to build out some new geometry there. And what I want to actually do here is add in a lattice feature here to regulate the flow through that channel. So this might be something that we're creating using additive manufacturing. And to start with that, there's really a lot of options. So with this lattice, we'll first begin by specifying the surfaces or the area that we're going to use to define where that lattice should be placed within. So this is something that we call a lattice region, where we simply go through and select on any of the edges we want to define that region. Latticing is a feature that's really something that we've had to focus on over the past couple of releases of Creo. It gives us the ability to create some really robust, complex structures that have a lot of different uses, especially if you're working in the world of 3D printing. And so quickly go through, define the coordinate system, state where that first cell should be located, and then we can define what that cell shape will be. And so we have a lot of different 3D shapes with those lattices, so kind of like what we're doing here with more of a 2.5D shape in the shape of a hexagon. If it's a little bit big, we can scale it down and then go through and change whatever parameters associated with that. If it looks a little bit thin, we can go ahead and increase that wall thickness by a bit, quickly visualize it to see if we like it. And if we do, go ahead and accept those changes. Again, even though I made a fairly significant change there, you can see the analysis is already updated. And then we can analyze the effects. Go back and change the display state there, change the result type we're getting, maybe see how our pressure has been dropping around those lattices, if that's something that we're interested in. So we can definitely see it's a little bit different than what it was before. Check back around the velocity of the outlet of my muffler, see that we're getting maybe spikes or the values changing, whatever you want to look at back around there. And once I've had the chance to look over those results, and because I'm in the design exploration, we can simply take those values and build out a checkpoint that allows me to see exactly the changes I made in order to get here. And if I'm happy with where the design's at, I can actually choose to accept those changes. And once we do, those changes are then applied to the parametric model that I started into the session with. And even though design exploration is a great tool, I don't have to be in Dex in order to work with this. This could be even a day or two later. Someone on my team says, hey, Paul, we need to decrease that outlet velocity. Well, I know to decrease that outlet velocity, maybe a good place to start might be around that diameter. Maybe you want to increase that a little bit. And once I make that change, we can simply go ahead and regenerate the model. And then my analysis updates right along with it. And I can go back, I can check the probe out, see that the values that I'm getting for that velocity have definitely dropped down a bit. Seem to be getting now around 240, 250 meters per second. And that's really the main idea with the flow analysis in CSL, is we're making any of the changes you want. Try this, try that, try anything. You don't want to limit the amount of creativity you have in your design by having to wait around for results to come back from the analysis. Now go ahead, simply build out the model that you like and immediately get that instant insight back. So that's just a quick look at one of the examples going through in Creo Simulation Live, specifically with the flow analysis. And if that isn't something that you've worked with around before, there's a lot of other options with it as well. There's a structural mode. You can go into looking at thermal studies, look at vibrations. So really a lot of different options that you can get into and actually build into your design process. Good look through there. And now next I want to move into our next section, which is going to be covering over multi-body design. So this is just offering a new way to design in Creo. And this is really built out in order to enable some of those capabilities like we have in the flow analysis, where you can use things like multi-body to build out some of those inner domains or outer domains, just things of that nature. It's enabling a lot of the applications we have now. And so it changes the way we design a lot of times, where each of those different bodies can be handled differently, different materials included or excluded from your mass calculations, how you define your global interferences or clearances. There's many options using this. It's something that's going to be supported mostly everywhere in Creo going forward. And those bodies that you create, they're entirely new object type in Creo. And they appear right in the model tree under your bodies. And each of those bodies can have their own individual appearances, parameters, attributes. With each of those, we have the different operators for working with the geometry: merging, subtracting, intersecting. And once you've done what you need to do, go ahead and make part files out of any of those bodies. Something that's a really powerful way to work. If you've never worked with multi-body before, it's definitely something that you'll want to try out. And for a lot of people, the standard way that we're used to working in Creo, it's going to work just fine. It's still an awesome way to work. But for a lot of other people, this type of Boolean work where you're merging and subtracting bodies and doing it in that way is going to open up a new world of possibilities. So doing that multi-body design might be able to get you there faster and easier for some geometry, as opposed to your typical surfacing and quilt-based workflow. So just a couple of different options there in that sense. And we also had improvements over in the world of additive manufacturing and 3D printing. And first is the creation of stochastic lattices. We've really done a lot of work on this, worked with the solvers that it's working around, and enhanced the way that this type of lattice in particular follows along some of the hard edges that we have in our parts. Just making the structures even more structurally sound. This is really useful in a lot of medical areas where you're creating things maybe like bone grafts, or just trying to follow around particular areas around that. So that's something that's been having a lot of work done around it. Next, we have improvements to the custom lattice cell as well. So this is where you're taking a part file in Creo and you're using that as the cell for the lattice. Where in the past, we've always had the option for full geometry, but now we've also included an option for a more simplified BREF geometry as well. So you can go through and define it either way. So if you're going to be building out, 10,000 or 100,000 of these different lattice cells, you'll probably want to go ahead and do that BREF geometry to go ahead and let it propagate a lot quicker. And then in this area as well, specific to the additive manufacturing plus extension, we made improvements to the tray assembly definition using that multi-body design methodology. So even within the same part file, you can have different bodies with different parameters, wall thickness, colors, a lot of different uses in that sense. And on almost the opposite side of things, in subtractive manufacturing, we also made improvements over here. So kind of in the machining world, where first we now can view synchronized toolpaths right in the graphics area. So we've always been able to synchronize those toolpaths, but now there's a synchronization menu where you can highlight on what you want to see, view them, and then just really keep track of it right in the design environment. And here, again, we've always had go home commands, but now some machines that you have need multiple go home positions. So especially if you have mill turn operations where you have both of those operating at the same time, you could have home 1, home 2, whatever you need there. And finally, the ability to explicitly call out Swiss turning operations. And so this is helpful if you have a mill turn machine, You can say fix the z-axis, put all the appropriate CL commands into the output file, and that's going to be a function of our complete machining suite of tools there. So if that's something that you work with, definitely a welcome site into working with those type of machining capabilities. Then moving on here, we've also made changes in continuing to support the work that we do in detailing and how that relates in with our model-based definition. So this is really a forward movement in the world of CAD today, and taking a lot of the information that was typically done on the 2D side with your drawings, and then how we're starting to really build that into the 3D models that we use to define those. So we have a lot of really good work being done around that. So first, of course, we've included multi-body support in our drawings. If you have different bodies with different materials, even if they're in the same part, you can go and make those different cross-hatchings to kind of differentiate between the different bodies. We have repeat regions in the drawings for those multi-body parts. Exclude certain bodies, include that all in your tables. Then over in the drawing tree and in the drawing model tree, you can control those different bodies, identify them, hide them, and just your way of keeping it all straight. All right, we can here configure our drawing view tooltips. So if you click on a view, see what the part is, the model, the combination, or explode state. We also have a new summary view command where we can click on an element and have the system tell me about it. It's a good way to understand the design intent. If it's something that maybe you haven't worked with in a while, or even if you weren't the one that created the model itself, good way to see that. We have improvements around the addition of drawing tree columns. So adding those in now is an option around that. And around that, being able to support and sort the drawing tree by view models and by parent views. So build out the drawing tree however you like. Next, we have improvements to removing hidden lines. If you have a view that you want to remove some of those lines from, it's much easier to do now. You can also move the arrow with the name. So you can have a link between the two. So whenever you move that name around, the arrow is going to follow, or you can kind of break that link and have it be separate if you like to. Right. And so also with that, we have the ability to add multiple leads. This is an option where you can have multiple normal tangent leaders all coming off of that one GTOL or that tolerance. So it's really helpful for creating those and creating nodes, symbols, anything that might be referencing separate areas, but you want to have it linked back to that same part of that same feature that defines them. All right, so next, being able to align ordinate dimensions with the baseline. This is something that you're going to run into if you're working with the ANSI standard. That's how they like to do it. So we built out those ordinate dimensions to work well with that baseline. We can control the length of intersected contours. So beyond that base intersection point, you can enable intersection witness lines to kind of guide that. And then we have our child view identification. So it's very easy to see where your drawings go. It's especially useful if you're working with a multi-page drawing, or maybe even again, if you weren't the one that created that drawing, it's helpful for keeping it all straight and understanding exactly where everything leads to. And we've continued to make improvements around GTOLs. So now additional indicator values, things like intersection or collection plane for angularity. In that case, it's working more in the ISO standard. Also have options for controlling the gap between your GTOL and the indicator frames. So depending on the standard that you're working with, maybe if you're working with ISO 1101, 2012, or 2017, you have different options for that potential gap size. And around those standards, as they keep getting released, Creo is going to keep evolving right along with them. So now we've imported or included the support for that ISO 1101 2017 and the ASME Y 14.5 2018 as well. We have options for the alignment of spacing when it comes to our composite GTOLs. So depending on how you want those GTOLs to align on the left, on the right, that's all done keeping up with the standards. Added in some new symbols to the symbol palette, particularly the angularity symbol for an intersection plane. We have the runout symbol for a direction feature and symmetry symbol for a collection plane. So if you work with any of those, that's a nice added feature there. And finally, we've updated the parser for our syntax checker. Again, taking into account those new standards, making sure it all works. So this is something that a lot of people in a lot of different industries are starting to work towards, is really building a lot of that information around tolerancing the dimensions and a lot of things that were normally created in our drawings. Now we can have that all tied in with that model and have a lot of really rich content around that. So we're always going to keep kind of building that out as we go forward. And so touching now kind of back on a different area here now is around generative topology optimization. So this is one of the biggest developments with the release of Creo 7 is the introduction of generative. So this is something that, in short, autonomously creates optimal designs that you have from a set of system design requirements. Within Creo, you're able to specify requirements and design goals, and the generative engine is going to automatically produce a manufacturable part, either maybe as a starting point or maybe even as a final solution. And that allows you to try out a lot of different things, different materials, different physics, manufacturing constraints, and automatically generate that geometry. It allows you to try out many different generative design studies to explore all different kinds of design alternatives and compare the results that you're getting between each of those to start to work towards the most optimal design. You're able to, while you're doing that, visualize all of that generation real time. And even whenever you're modifying your input geometry, change your design criteria, go ahead and run right back through that. And that process allows you to interrogate and review all of the analysis results you get after generating the model. So see what your stress values are, what's the deformation, and you can see as you start to get those results, you can go back through and change things, change around those design constraints, any of the geometry, try different materials, and see what that does to the model and what kind of geometry that you're getting. And we're really able to do this because it's all integrated right in with Creo. We've integrated this frustum technology that's the base for it right into the modeling environment. It's not some separate window or software you have to switch over to. And all we do is define the geometry, say what we can change, say what things we can't change, any constraints, and just let the system go. And once the system generates that design and you've had the chance to review it, go ahead and output the results to use elsewhere in Creo for further refinement and any optimization you want to do. And so to do that, we can take that design and convert it then into BREP geometry. So in that process, you have different options for how the model is reconstructed. You can go back and forth between the two, see what's changed, really do that to get the best model possible. And at the same time, with manufacturable geometry. It's one thing that's nice to look at that tessellated version of the model that if you couldn't actually create, but what you can do in Creo is really take that geometry and build it into what we call curvature continuous. And so it's actually manufacturable geometry that you can create once it's time to go ahead and manufacture these parts. And what we can do here is jump into a brief demonstration to kind of show what that would look like here in the context of Creo and specifically 7.0. Right, and so here's our model here that we took our muffler off of earlier, actually. So this is coming from the data set we have from Royal Enfield. This is one of their first motorcycle designs. Specifically here, what we want to look at is up in this steering mechanism. We have this lower yoke. And right now, works perfectly well. But it's something that maybe I want to see that, I want to cut down on some of the material costs around it. I might know some of the design goals I'm after, but I'm not exactly sure how I'm going to get there. Well, that's a perfect candidate for generative topology optimization. So what we can do is go ahead and open up our part that we want to use to get working. And here we can see I have that same yoke part, but a little bit more of a simplified version of it. So this is going to be the base that I'm going to begin to work off of. So the first thing that I'm going to do is I can show you the start, is kind of the overall envelope of where our generative part is going to be contained within. And then the other part here that I have is my preserved geometry. So what that is more of the area that I want to keep. So once this design's built out, this is the area that I want to make sure is part of that end model. And what we're going to do is really build out in the middle of that. And if I want to begin to work with it, simply head up into my applications tab and go into our generative design. And here's our general interface that we work within. Again, it's not some other separate module we jump into. It's right in the context of Creo, or in the same general UI that we're used to. And so we can go ahead and select our starting geometry, which is going to be that overall envelope we saw. And then we'll select our preserved geometry. Again, the areas that we want to make sure are going to be included in the final design. And from there, we can lay out some of the physics. So we can first lay out where it's going to be constrained down. Maybe there's going to be a pin going through there. And then the loads or the forces that we want to look at here. So over on these outer yokes, go ahead and apply whatever force that we're looking at there. Go ahead and type in any of the magnitudes, the directions, units that you want to include with that, and go ahead and keep moving. So that's essentially the base there, and then we need to decide what we want to design around. Well, in my case, I want to be able to take weight out, so I'm going to go ahead and fill just about 2/3 of that volume. And once we're actually building out to decrease that weight or decrease the volume, we're going to have some design constraints. This could be manufacturing constraints where we need to take into account the build direction for additive manufacturing, maybe a parting line if we're going to be doing a cast, or it could be more of a geometric constraint. Here in this case, I want to use the planar symmetry. And what we're doing there is just making sure that everything that we do over on the left-hand side is going to be the same as what's happening on the right-hand side. And finally, we'll select the material that we want to work with. In this case here, we're going to be using an aluminum alloy, and that should just about cover everything we need in our design criteria. Final thing I can look at before I go ahead and run the study is some of the settings. So we have options for the fidelity to optimize on either speed or detail, minimum element size for our mesh, or even a maximum amount of iterations that we want to run. And with all of that laid out, everything's ready to go. All we need to do is simply go up to the top and click to optimize. So now the system is running through and taking all those physics, the design criteria, and it's automatically building out our design. We can visualize all those steps real time, and from there, analyze the results we got from the study. So here we can see right on the model, take a look at the von Mises stresses, see exactly where we're getting minimums, maximums, move up on top of the model maybe to see and check where our hotspots are going to be, right up in those corners. Even check out the displacement if we'd like to, kind of see if this part is deforming the way that it should be based on the loads and the constraints that we set up. And even take it one step further and animate on that deformation. You see we have some options to change the speed of that animation, change the scale. It's really a very visual way of doing that. And if we're not happy with the results we got, just as easy to go back and make changes to the definition of the study. But if I am happy with the results that I got, then I can go ahead now and choose to generate that design. So right now, I just have all this tessellated geometry. But what I'm going to do from there is reconstruct to a boundary representation, aka BREP, that I could take now over into Creo Parametric. So rather than being just stuck with that tessellated file, we can actually get that real manufacturable geometry that we can now work off of. Right, we can see now that Creo is starting to reconstruct all that geometry that we just went through and built out in the study. And now it's all part of that Creo model. And I can go ahead and add that right back in with my part. So simply just here using some Boolean operations to merge in our new geometry and add that right back in with the preserved geometry that we started with. And just like that, we have a solid Creo model that's ready to go. But a lot of times what happens right now is we need to make changes, right? Maybe at this point the model changes, possibly that outer diameter moves. So does that mean now that I have to start my study all over from scratch? Well, no. We can simply just go back in and change around what our design goals want to be. Maybe switch up some of the design constraints. Maybe now that we've had the chance to review this, we now know that we don't have a 3D printer to actually create these designs. Well, that's not going to be a problem, right? We can simply just add in any constraints we had before. And maybe now in this case, we're going to build this out as a linear extrude instead of leaving it with just that geometry that's only really possible using additive manufacturing. This is something that we can build out in all those different ways, right? In this case, we want to build it out knowing that we're going to be extruding this over in the shop. Right, so go back in, redefine any of the materials that we're working with, and then go ahead and run the study. And before we do that, we can still go back in, change any of the settings up. We can change the fidelity, change up the maximum iterations that we want to run, and go ahead and let the system do its thing. In this case, I've already gone through and run this study before, so instead of running through again, we just go ahead into our File Explorer and open up the result that we got after converting to our BREP geometry. So taking a look at this, whereas before the design was really only possible using additive manufacturing techniques, this is another part that can be manufactured other ways, like extruding, milling, casting. So we can go ahead, add that geometry back in, and we have a part that's ready to go. This is something that now we could take back into our other simulation areas in Creo. So like I mentioned earlier, like we saw with Creo Simulation Live, that was more of a flow example, but it's a lot of different areas we can work in as well. So like here, we can do more of a structural study, where we're looking at different constraints, different load cases that this might be forced down by, and go ahead and run that simulation. And we can see, again, pretty much as soon as I click to run the simulation, we're getting results. So I could go back and try out all different kinds of designs through generative, then reconstruct the geometry, take in any of those constraints and loads over into my simulation, and see what kind of results we're getting. So looking at what we got here, it's definitely different than what we would get working with the additive model. You know, deformation around those outer holes has changed. We can further animate on it to show that deformation if we'd like to. And then we can go ahead and take that info, run more analysis if we'd like to, go back in, make more design changes, whatever you want to do. Take it in and really build out the part in the way that you want. So at the end of the day, you're using generative to create really innovative, but at the same time, structurally sound models throughout that process. A quick look through what that general design process looks like working in generative design. So I wanted to take you through what that looked like, but now I want to take a next step and take into a little bit more what we have with some of our other applications. Moving on from here, we have a new few options over in Render Studio as well. First thing here is the ability to pause and resume during the rendering. Or normally if you're in this mode, it's kind of constantly running by default. But now if you kind of know that you're going to need to make some changes, you can simply just pause that render, give the computer a break. Another awesome tool here is now being able to render the mannequin vision window, essentially taking the view of what the mannequin can see. We're able to render that view to get some really nice shots. We also have the option to define a custom floor plane for the render. Allows you to flip the model, change where the shadows and all the reflections are going to appear, and just in general, much easier to work with around doing that. So a couple enhancements over there in the world of rendering. We also had improvements over in the world of augmented reality in Creo as well. And if this is something that you haven't worked with before, this is something that has been built out and really improved upon over the past couple releases of Creo. I think since Creo 4 it was introduced, and it's instead of just sharing out screenshots or sharing out the model and hopefully they're able to open it up, you can share it out in more of an augmented reality view, where you can simply just send over a code to somebody and they can simply scan it up right on their phone and then see the model right on their desk. They can scale it around, rotate, see different views of it, and we've really had a big stake in this in the context of Creo and how we share these designs out. And especially now with Creo 7, we now have the ability to publish different combined states as part of the experience. Those combined states can include exploded views, different section views, different appearances, so that can all be included now. And with each of those different states, the user can switch between each of those. So very quickly and easily switch from one view to the next. And you have a lot of different view options for whenever you're publishing over to Vuforia View. Vuforia View is our free to download, free to use application that we're actually using for pulling up and viewing those augmented reality experiences. So if that's something that I haven't worked with before, that's a base capability here in Creo, something that you're definitely going to want to try out. And finally, I'd like to just briefly discuss on some of the improvements over in the easy tolerance analysis tool in Creo, or formerly known as the tolerance analysis extension. And if this is something that you haven't seen before, this is a one-dimensional tolerance stack-up analysis tool. This is powered by one of our partners, Sigmetrics, and we're using this to perform these type of tolerance analysis on our Creo assemblies. Something that you can do right from the Creo design, works right from our annotations for our dimensions, tolerances, GD&T information, and as you make changes, have all those changes propagated to update your analysis data. And so with this change, we've really done a lot to update the look and the feel of the tool, made it even easier and faster to do these type of dimensional stack-ups. We can define multiple different stack-up analysis right on that same model and evaluate a lot of different impacts from the studies. Look into things like statistical results, defects, worst case scenarios, RSS values, and then even checking into which annotations or which tolerances have the highest contribution to those results that you're getting. So if we're seeing that one of the values or one of the areas or features that we're getting, maybe that's having the highest contribution, that might be an area that we might look to see, okay, maybe we can tighten up some of those tolerances, or just in general, how we can really build out for the results that we're looking to get. So something that's really powerful there and a really useful tool if you're looking into doing that type of tolerance analysis. And with that, that's pretty much everything that I wanted to go over in the context of what's new with Creo 7 today. So obviously a lot of different areas there, a lot of different applications. Maybe right now you don't work with a lot of that, or maybe you do, but don't work with all of it. It's really, I'm trying to give someone a little bit to everybody here and open up your eyes to working with some new different things here in the context of Creo. So definitely a lot of things to explore, and definitely things that I can elaborate on for right now if you'd like to, right? So ask any questions you have, allow me to elaborate on anything. And if there's anything that you wanted answered after the call, feel free to reach out about that as well. We can get that answered for you too. But
Thank
with
you,
that, I
Paul.
can pass it back over.
Yeah, thank you, Paul. What a great overview. I'm sticking around a few more minutes to see if we have any questions or comment. And in the meantime, I'm going to show my screen. So I first of all want to thank everybody for attending today. I also want to show you where you can find the amazing new Creo 7 at novedge.com. And also want to let you know that we're running a special for the next couple of weeks on CAD workstation perfect for Creo. And I don't see any question, Paul. What a complete tool. I was very impressed. And if you want to watch this webinar again, because it's being recorded, you can go over on Vimeo and YouTube, just search for Novedge, and the webinar will be there for you to share with your boss, colleagues, and friends that use Creo with you. Thanks again for the awesome presentation, Paul. Have a great rest of the day. And bye-bye, everybody.
Yep, have a good one.
Bye.